Good morning, student. Let's start today's class. Okay. Today we will going to study about equivalent circuit diagram of a solar cell. That means what is the equivalent? What can be the equivalent circuit diagram of a solar cell? You can see in today's class. Okay. This is the equivalent circuit diagram of a solar cell. Okay. This is our solar cell, and this is our equivalent circuit diagram. And a solar cell can be represented by an equivalent circuit diagram as shown in figure. Okay, since a constant current generated inside the cell when sun ray incident on the cell surface, so we can consider a solar cell as a constant current generator. That means since whenever the radiation or sun ray fall on the solar surface, it generate a constant current. Okay, so we can consider a solar cell as a current generator, constant current generator. So here IPH is a constant current generator which generate IPH amount of current. Okay, then but when there is no irradiation, okay, there is no sun ray fall on the solar cell, the solar cell worked as a normal semiconductor diode. Previously I told you the efficiency of which remain constant even when the radiation fall on its surface. In equivalent circuit diagram, therefore, one should connect a diode in parallel with a constant current generator. That means since whenever there is no solar radiation fall on the solar cell, then the solar cell act like a general PN junction diode. Okay, so we can connect a PN junction diode in parallel with our solar cell or constant current generator. Okay, then the resistance which are in series RS, this resistance, okay, RS, okay, and or in the parallel which is RSH, this is the resistance RSH. Okay, this is RS, this is RSH. Okay, RSH in the circuit have a considerable effect on the efficiency. Okay, this resistance uh, can make an effect on the efficiency of the solar cell. Okay, in a good silicon solar cell, the RS is kept small. Okay, that means this RS is very kept small so that the efficiency of the solar cell is getting high. Okay, or is very high. Parallel resistance RS cause a drop in the working voltage and the large the current flow. This parallel resistance, due to this parallel resistance, here here voltage drop or here voltage drop happened, so that a large current flow which is ISH flow through it. Okay, that means the in the resistor through in the across the resistor parallel resistor RSH, the high amount of voltage dropped are there, as a result high amount of current flow through it. Okay, so the drop in the working voltage causes a reduction in the fill factor. Okay, the drop of the voltage in the RSH, okay, causes the fill factor or reduction of the fill factor of the solar fill perform curve. Okay, Then the output terminal current I is equal to the light generated current IH less the diode current ID and the start uh, current ISH. Okay, sorry, short current. Okay, short current ISH. That this is our load current I. Okay, and this load current is equal to ISH, okay, no, sorry, IPH, which is generated from a solar cell, and minus ID minus ISH. Okay, that means IPH minus ID. Uh, you see, ID minus I. Sorry. IPH minus ID minus ISH. Okay, ISH equal to I. You see this current going here also and here also. After that we get I. So from this current we minus this current and this current to get I. Okay. This then the series resistance RS represents the internal resistance to the current flow and depends upon the PN junction depth. The series resistance, this resistance Rs is represented as the internal resistance of solar, okay, solar cell. So the current flow through Rs depends upon the depth of the solar cell, that means, or a PN junction. So PN junction inside solar cell, that means how much depth or more depth are there or more width are there of PN junction, more resistance are there. Okay, so more current are there. The shunt resistance is inversely related to the leakage current to the ground. Okay, in ideal photovoltaic cell, PV means photovoltaic cell, Rs, which is series resistance, is 0, so no series loss, and RSH, parallel resistance, is infinity. That means no leakage to the ground. Okay, so in a ideal photovoltaic cell, the resistance also 0, series resistance is also 0, and the shunt resistance or parallel resistance is infinity. Okay, in the equivalent circuit, the current delivered to the external load equal to the uh, current IPH generated by irradiation less than the diode current and the ground shunt current. Okay, in previously I told you that the load current is equal to the IPH minus ID, okay, minus ISH. Okay, open circuit voltage can be obtained when the load current is 0. Okay, open circuit means there is no load. Okay, one circuit is open when, if we consider PN junction as a open circuit, so this is PN junction or our cell. Okay, cell, then there is no connection between this and this, or there is no connection between connection of load. Okay, so at that time it is called a open circuit. Okay, so here since there is no load, there is no load current. Okay, so I is 0. Okay, a VOC means V open circuit voltage equal to V plus IRS. Okay, this is IRS, this is I into RS, not this is I, this current, this current IRS, okay, this current. I into RS, okay, I here I into RS, okay, here I into RS, okay. So the diode current ID equal to IS, okay, E into VOC by AKT minus 1, okay, where IS, this IS is saturation current of the diode, okay, and E is electronic charged, which is 1.6 into 10 to the minus 19 coulomb, okay, and VOC, you know, open circuit voltage, okay. Then A is, okay, Korb filter constant, okay. K is Boltzmann constant, which is 1.38 into 10 to the minus 2 meter uh, joule per Kelvin, and T is temperature in Kelvin, okay. Remember this formula ID. And so the load current I equal to IPH minus ID minus IS, okay. So I equal to IPH minus ID, the value of ID in the place of ID, and the value of IS in the place of VOC by RSH, okay, VOC by RSH, okay. Remember this formula also, okay. Thank you.